when it will going on. Okay, that is the second process. And in this process, they will release the heat also. Okay, that is why we call this process. In this process, they will release the heat, exothermic process. And you observe, they will release the heat for only for fluorine, bromine, and chlorine only. For iodine, these processes are endothermic only. Okay, and I will tell you step 3 what happened. Now, in the step 2, what happened? So what happened? Both will come because in step 3 they want to terminate the chain. So what happened? This chlorine will come. Okay. Now CH3 will come. Free radical methyl group will come. Both they will make ethane. Don't panic now. Ki what sir? How it is ethane will come? I will tell you. Okay. Now this CH3 free radical methyl group chlorine will come here also. They will make methyl chloride. Okay. So what happens? This compound make in the last very big amount. These two compounds will make, but it's very compound are very less. You can say 0.01%, 0.02% only. So that is why we are not talking about ethane. Okay, in this process. So don't worry, sir. Why we are not talking about methyl? Because is their amount very less. Okay, so that is why this method. If you do not have control the amount of chlorine या alkane, so what happens? Again, this methyl chloride will again they will make double CH2 Cl2 here. Now I'm explaining already here how to make. I will not explain again process. Okay, and the last they will get on the 2 carbon ClCl. Okay, and this process will go until the CCl4. If you will control, then you will stop the reaction here only. If you have control, so you can stop reaction here only. If you not control, so this process will going on continue to here. Okay, it is clear. This mechanism is very simple. It's not a tough. It is the related to 11 class. Okay, hydrocarbon. Okay, guys, in the halogenation reaction, your reactivity of halogen is like this: chlorine, bromine, and iodine. I will tell now. Whenever you see कि fluorine will be there, the fluorine will react very fast with alkane. Okay, combined to chlorine and bromine and iodine. Okay, I am written also a reason here, but it is not important for you. Just remember कि fluorine is more highly reactive compared to chlorine and bromine and iodine. Why? Because I'm reasoning because sometimes you can feel कि if you want to break the bond now, if you want to break the bond, so you have to give more energy in the chlorine case. So if you want to make breaking the bond and you want to make the if you want to break the bond, in this case chlorine will be highest taking energy. So you can say according to bond breaking, you can say chlorine will be more highly reactive, but it's not happen. Why? Because whenever you will react with alkane group na free radical halogen, whenever free radical halogen will react with alkane, so in this case heat will generate. So fluorine only one element who will generate so much high heat. So that is why we can say कि fluorine is very highly reactive matter. Sorry, you can say fluorine is very highly reactive element compared to chlorine. So overall your fluorine is very highly reactive, then chlorine, then bromine, then iodine. So please remember every time this order you have to follow. Okay, then I'm saying whatever mechanism I follow for chlorine, same mechanism follow for bromine also. So bromine also same. Okay, do not feel ki bromine is different and chlorine will be different now. Whatever mechanism I follow for chlorine, bromine is also same for simple structure. Okay, now fluorine will come. I tell in the class also ki why fluorine is will not possible, because of whenever fluorine will act with the alkane, they will generate so much high heat. That is why we are not suggested in the lab, yeah, in the industry. So what we do for fluorine, if you want to make a halogen with fluorine, so what they will do, they will use halide exchange method. This will tell you in the class, no problem. Okay, I just mention only ki because it will generate so much high heat, that is why we are using halide exchange method for fluorination. Okay, and iodation case I also discussed in the class. Ki when you will take iodine in the presence of light, they will make methyl iodine. But here HI will be there. It's very strong reducing agent. So that is why for finishing the HI, we are using HiO3 या HNO3. Okay, I mentioned also here. If you are using HiO3, HNO3, what they will do? They will convert into I2 plus water. So because of if you are using in a alkene group with I2 in the presence of light using HiO3 or HNO3, in this case this Hi will develop, but this HNO3 HiO3 will attack on the Hi, they will convert into iodine and water. So there is no concern here. So that is why whenever you using iodine, just use this two reactant answer. Okay, two reagent answer. Okay, guys. Then you will get this CS3I. Okay, that is a basic. Okay. Now I will go to chlorination of ethane. What happen here, guys? See, if you are doing chlorination of ethane, so what happen here? So you guys already know here what happen. One chlorine will add in the ethane group. Here one chlorine, then here two chlorine, then three chlorine, four chlorine, five chlorine, six chlorine will add. Okay, this is simple like methane group. Okay, so here if you look on the if you're looking for the mechanism, this is also same like chlorine will take in the presence of light, chlorine will break in the free radical form, and this chlorine free radical very highly stable, they will attack on the ethane group. Because of that, and this free radical group, you will take one hydrogen, they make HCl first, then you will get the free radical ethyl group. Then this free radical ethyl group will attack on the chlorine. They make one chlorine. They will make one bond and they will release one radical chlorine. Then this chlorine will again attack on the ethyl. This process will going on. And what happened in the last chain termination? We have C2H5 dot and Cl dot. What happened? These two dots Cl2 dot, they will make Cl2, and this C2H5 dot, they will make C4H10. You can say, sir, here we are making butane. Yeah, here butane will form. And also here C2H5 dot will make with Cl, they make C2H5Cl also. But guys, remember one thing, I will tell now also, this CH410 is very less. So don't worry about that. It's very less. So that is why it is not our concern. If you say, sir, if you are doing chlorination for ethyl group, we can butane, huh? We can get, but this amount is very less. So that is not our concern. Our concern only C2H5Cl. Okay. But here, one question they're asking in the JADVANCE sometimes. What is the question here? In the JADVANCE, they're asking, okay, if you are doing, if you're taking excess amount of ethyl group, ethane group, and you're doing a chlorination in the presence of light, so what product you can expect, okay, with HCl? So P, means product can never be C2H5Cl, C2H4, या C4H10 या non. So guys, I already tell here, if you're doing chlorination of ethyl group, so what you will get? C2H5Cl you will get, C4H10 you will get, Cl2SO you will get. I know this amount will be major and remaining will be very less. But guys, this here is also mentioned one ethane group. You guys see here is ethane. Can we expect this ethane also here in the chlorination of ethyl group? Yeah, we can expect. Okay, why I'm telling you why. It's very less amount. That is not our concern. But we can expect. At JDVANCE, this type of question they will ask. Okay, because JMIN will not ask. NEET also not ask. But JMIN JDVANCE can ask. Okay, this type of question. What happened actually? I told you na कि we have a free radical group. We have free radical ethyl group is there. Yes or no? What happened actually here? कि these two carbon we have. Okay, I will make here. Here here three hydrogen is there. Here two hydrogen only there. Here free radical group is there. Here also free two hydrogen and this will be there. So what happened here? Ki if I will take this hydrogen, if this see this ethyl group radical very high unstable. So he want to make only bond. If you take this hydrogen to this side, so what happens? This carbon take this electron. Okay, both electron will go to this carbon. So what happen? So in this process, what happen if see if this hydrogen electrons, if this hydrogen electron will this carbon will take both electron here. Okay, so what happen? This carbon will make, see carbon already have one free radical electrons. Okay, if carbon will take this electron also, so what happen? Here can we make double bond, and this hydrogen will go this side, they will make a hydrogen also. So in this case what you have said, ki here two alkane group is possible with C2H6, C2H6 with ethane. Here ethene group also is possible, but is very less. So that is why we are not discussing. I think I will write very invisible color. I will write here C2H6. It is a ethane. Okay, why? Because see, I will write here. Don't worry. See this H electron. See this carbon take this electron towards this side, and this electron hydrogen will take, and this hydrogen will take this electron and will make here bond with this carbon, free radical carbon. Okay, and these free radical electrons and this free radical make double bond here. So in this case, you will get ethene group. So in this question, you can expect C2H4 also, C2H5Cl also, CH4H10 also. But I am saying now also, this will be major compound. Both are very very less. So if they will say, if they see when they will comparing, then you have to think. If they will not comparing, don't think, just tick only this A. Okay. If they are asking to comparing, then you will think proper way. Okay, what will be possible? Otherwise, you can just tick and you will go ahead. Okay. Only they will ask in the J mains only. Okay, those are J ones only. They will not ask in the J ones. Okay, so J mains. Okay, don't worry about that. Now I will tell you what this thing I discussed in the class. Now I will also discuss again. Okay, this thing is very important. Bhagya Arshit, what are you doing? I see. See, I doing chlorination for propane. Okay, in the presence of light. What happened? Guys, see, this chlorine will have to two chance. Go to 1 degree also and 2 degree also. So this chlorine will go to 1 degree also and 2 degree also. But in the 1 degree they will make 45% and 2 degree they will make 55%. Okay, they will make 55% also. If you are looking this, they also explain. Okay, why this is happening? I will tell you, guys. See, why both compound is possible. I will tell you reason first. Okay, then I will tell you how this percentage will come. See, guys, when see because of see when we are doing when we have free radical group, okay, and this will attack on 1 degree or 2 degree. So what happens in those both case? We will get this free radical group on this carbon. Yeah, one time we will got this free radical electrons on this 2 degree carbon. So what happens? See, in this case, this second degree carbon will be more hyperconjugation is possible. Why? Because it's a 6 alpha hydrogen. Here only 2 alpha hydrogen is possible. So that is why this free radical carbon is more stable. So that is why it making the bond with chlorine also. But you can ask, sir, we also see now 45% is also possible for first degree. Why? Because why it is possible? See, for 1 degree, if you see looking here, it is 1 degree here also, 1 degree also here. So 1 degree hydrogen is here, 6, 3, also here 3. Means 6 1 degree hydrogen is also there. Means if chlorine will proper collision with this 1 degree carbon, so there will be chances they will make the 1 degree halogen group also. So that is why here 6 hydrogen will be there. That is why there are also more chance they can make the 1 degree halogen group also. And how this percentage will going coming here, I will tell you. Okay, don't worry. Okay, I will
Sir,
see here.
sir, sir, why 2
Huh?
degree?
2 degree. See, see, if I have free radical, just 1 second, I will explain it. Okay, see, what happened? This free radical chlorine will come. Okay, this free radical chlorine have two chance, 1 degree or 2 degree. Okay, so 2 degree free radical. If you see here, 2 degree free radical electrons are there. You know, 2 degree free radical have 6 alpha hydrogen, 3 and 3. Means here hyperconjugation is more possible. Here 2 alpha hydrogen only there. Means here two only. So here hyperconjugation is less possible. Here hyperconjugation is more possible. So that is why in this case 2 degree carbon free radical is more stable compared to 1 degree. Okay, that is why they're making 2 degree halogen group. And 1 degree they how they why they making, because here 6 hydrogen is there. So here also chance if chlorine will come, so proper collision will happen with 1 degree hydrogen also. So here is more chance collision proper collision will happen. So that is why they are also making 1 degree carbon. 1 degree halogen group also. In bromine, if you see, bromine is same thing also happen here. Is a bromine 2 degree and bromine 1 degree. Okay. And bromine, this is a major, is a minor. But one thing please remember me, in bromine case and iodine case, this will be very major. It's not about 45%, 50% not. Is I think it is about 99%. Yeah, 98%, this will be major. And it will be only 1% or 2% only in a bromine case. So that is why in bromine and iodine case, don't write first degree. Okay? Huh, both possible. But don't write. Just write only major component. Why? Because it's only 1% only. This is only 1%. This is 99 and 98% in the chemical compounds percent. So that is why you just write for bromine and iodine only 2 degree. Okay. Now I will
Why
go
is
shift to what happened.
why is like that, sir?
I will tell you. I will tell you in this lecture series. I will clear everything. Okay, don't worry. See, see. Actually, now here fluorine. I'm also here written here as a fluorine. If you take fluorine, what happen? You think that there will be second degree measure and minor also no. So in a fluorine case, second degree will not possible. Only first degree is possible in the fluorine case. Why? Because fluorine have very highly reactive matter, very highly reactive halogen group. So that is why they will select very least selective. Means they do not have time to select. Ki I will go to 1 degree or 2 degree because they have very highly reactive. So they just go to 1 degree. They will just make the bond. So that is why in the fluorine case you will get the 1 degree halogen group. Okay. Okay, I will make you also see. For fluorine, your you will not select the word of 1 degree, 2 degree, 3 degree. In fluorine case, they will see where is a more space is there. Where be more space is there, they will go to directly that carbon only. If you are talking about fluorine case, they will make more compound with 3 degree, not a 1 degree. They will make compound for 1 degree more than 2 degree, than 3 degree. Means they will go first degree, then they will go to second degree, then they will go in the last third degree. So in the fluorine case, first degree will make. Okay, why? Because steric hindrance. Because of steric hindrance, in third degree steric hindrance so much. So that is why fluorine do not like this stress. They just want to go only free area. So that is why in the fluorine case you will get 1 degree only. Okay, but in chlorine is very different case because chlorine have chance to select. Okay, they have selectivity as ratio also. I will tell you here in the next class. I will explain to ratio also. Okay, don't worry. Okay, so chlorine have chance because chlorine has some selectivity ratio. So that is why they will make sometimes 1 degree, 2 degree, or third degree also. But bromine iodine case always they follow the stability. Whenever you will going for bromine iodine, just follow the stability. Free radical carbon if you looking, so 3 degree free radical carbon is more stable compared to 2 degree than 1 degree. That is why according to this rule they will make the bond. So for bromine iodine, just follow this rule only. Don't focus on other things. Okay. But for chlorine, there is a some problem. You can say chlorine is a special case. See here, I'm written here. If you have chlorine, if you have chlorine, okay, 1 degree. If you have one group, 3 degree, 1 degree, 1 degree, and you can see here fluorine will take. Here we have take fluorine in the presence of light. We are taking here bromine in the presence of light. So what happens? See, I am written here also. If fluorine will go to first degree carbon, but bromine will go to third degree carbon. Why? Because for bromine, third degree carbon is more stable. So that is why they will go for that. But in the chlorine case is a different. Chlorine what will do? I will tell you now here. Okay. Actually, for chlorine, some ratio will be there. Selectivity ratio is there. For 3 degree, some constant value is there for chlorine. 5 for 2 degree, 3.8 for 1 degree is a one value. Okay, is a selectivity ratio. So what happen here? If you want to proportion, if you want to calculate proportion of 3 degree, proportion of 1 degree, then you have to how to calculate. See, here I have one compound CH3, CH3, CH, CH3. I will take chlorine in the presence of light and I will start the reaction. So what happen? This chlorine have two chances. It will go to 1 degree, yeah, it will go to 3 degree. Okay. So this chlorine will go to both directions, 3 degree also, 1 degree also. But how can I know which will be the major and which will be minor? So how can I know? From here. How? See. Guys, see proportion of 3 degree. How I will get the proportion of 3 degree? See, 3 degree constant value is 5. First write 3 degree constant value is 5. How much hydrogen of have 3? Praswal, now is Praswal is coming. See guys, for 3 degree constant value is 5. But for 3 degree carbon you have 1 hydrogen only. Just multiply with 1 hydrogen only. So what you will get? 5 value. And proportion of 1 how to get? For proportion of 1 degree you have only 1 constant value. Just write here 1. And you see 1 degree carbon has 9 hydrogen. 3 here, 3, 6, 9. Just multiply 9. You will get 9. So how to get the percentage of the compound? Just divide the percentage of 3 degree. How we will get? How much 3 is there? 5. Total 9 plus 5, 14. Multiply into 100. You will get around 30.5, 8 something. Just calculate by your calculator. You will get around 36%. To now, sir. Okay, selectivity ratio I will tell you again. Okay, don't worry. Hello? I will explain free radical substitution mechanism here. Now I am telling why chlorine is a special case. Okay. Praswal, can you confirm once you are here? Can you confirm once? Praswal, can you confirm once? Praswal, Arey, I'm not saying. Just you can say in a voice also, no? Okay, I know you did it, no problem. But can say only one two word? I can understand. You are here, not okay. Yeah, showing me your face. Yeah, you will just use one word. Okay, guys, it is a Praswal. It is not a Praswal, na? Guys, you
He
again
is
sharing
Prajwal.
yes,
Prajwal
yeah.
only, sir. Prajwal only.
Praswal. Okay,
Yes, sir. Prajwal only.
okay. So what is the Harshit here? See Harshit, for chlorine, the ratio for 3 degree 5, 2 degree 3.8, for 1 degree is 1 ratio. So this constant you will take to calculate the proportion of 3 degree. How we get ki 3 degree will make how much compound and 1 degree how much. So here we use this ratio constant. For 3 degree you just take how much hydrogen are there for 3 degree carbon. Only 1 hydrogen is possible here if you're looking here. So that is why just multiply 1 into 5. You will get 5. And 1 degree carbon have 9 hydrogen. 6, 3, sorry, 3, 6, 9. Just 9. 1 into 9, 9. So if you divide 5 by 14, 5, no, 9 plus 5 is 14. If you divide 5 by 14, you will get 36% around. If you divide if you divide 9 by 40, you will get 64%. That means for 1 degree you will get 64%, for 3 degree you will get 36%. That means here 3 degree is minor and 64 means here 1 degree is major compound. So that is a special case for only chlorine only. For bromine, anodine, they will follow the stability only. Okay. I will make also here. I will prove here. See, I will make for propane also. How they will get this 55% and how they will get 45% this. Just follow here. Proportion of 2 degree. Proportion of constant is value here. 2 degrees 3.8. Just take 3.8 here. Okay. And they will multiply with how much carbon have. See, this is a 2 degree. This first degree this is the first degree. This 2 degree carbon have 2 hydrogen. Just multiply 2 into 3.8. This will come 7.6. And this 1 degree proportion is 3 and 3 6. 6 and 1 degree carbon have only one constant. Just multiply 6 into 1. You will get 6. Now you will get the percentage 7.6 by 7.6 plus 6. It will come 30.6. If you divide into 100, you will get 55%. And you will get here 45%. Means for 1 degree you will get 45%. For 2 degree you will get 55%. That is why this is a major, this is a minor. Okay.
What is that constant?
Actually, it is a selectivity ratio. for 3 degree, 2 degree, 1 degree. Is the experimental value. Is not a calculation. Yeah, it is not a formula. It is only experimental value. Key for chlorination. For chlorination, for chlorination, this will be value. Okay, it's not like a formula. It is the experimental value for chlorination. 3 degree, how much they will have chance for proportional compound. That is why this is a ratio 5, 3.8, 1. Only for chlorine only. Okay. For bromine iodine, you have to follow normal free radical stability only. That is enough.
What's an
Okay.
experimental?
What?
That constant, how? What is that?
That I'm saying. It is a constant key how 3 degree carbon have can make the compound. You can say, okay. Because if your chances both na, so they will get the experimental value. Okay, this if you multiply this constant value to possible of hydrogen, so you will get the help to calculate the proportion of the compound in the chemical reaction. That is why it is a constant value. Okay, we are using. Okay, I also make for this also 1 degree, 2 degree for chlorine also. If you calculate by your home, okay, I will calculate 1 degree, 2 degree, 3 degree for this compound. Proportion of 3 degree is 5, proportion of 2 degree is 7.6, proportion of 1 is 9 degree. Means here 1 degree will be major compound. That is why here major compound is 1 degree chloride. And bromine, no worry, just for bromine you just follow who is more stable free radical carbon 3 degree, just follow only 3 degree. Don't follow 2 degree, 1 degree. But for chlorine, you have to check by ratio. Will be which will be more. Now it is coming another. Now you can confirm as well once.
Yes, sir. Confirm.
Okay. Okay. Thank you.
Okay. What you were explaining, sir?
Till now I explained the free radical substitution mechanism. Now I will explaining the chlorination ki how you will get the percentage of chlorination. Ki 1 degree, 2 degree, 3 degree, how much percentage will be there. So this thing I will explain in your lecture. Don't worry. I will share with you video lecture. Okay.
Okay.
After class.
Okay, sir.
Okay. Don't worry. I will share with you video lecture. Okay. After class.
Okay.
Okay. Don't worry. I don't know. My voice will come or not. I will just recording here. I will see if recording voice will come. I will share with you guys. Okay.
No.
What happened? See, guys. So for this compound, please calculate by your home. Okay. Okay, guys. And you will check which compound will be more percentage. You will get here. Okay. You will do by yourself. Okay. I already done this. Okay. Now this is already done. Okay. Allylic substitution mechanism. I will tell you in the next class. Okay. Uh,
Sir, we
One
have
second. One
tomorrow.
second. What you saying, Rajesh?
We have tomorrow class school.
Yeah, yes, of course. Why not? What happened? Tomorrow is Friday, na? I
No,
will take na your what?
health is not well. Health.
No, no, I will come. I will come. I cannot take more holiday. I will come. Don't worry, I will come. Okay. Mm, I have to explain some definition. I will not explain in the class because it will be time pass. That is, I am explaining here. Okay. See, I am explaining some definition here. Okay. I do some substitution action. If you know what is the meaning of substitution action, I'm just explaining some definition. It's only for 10 minutes. Then I will leave you. Okay. Don't worry. Just for 10 minutes. Just see. Okay. For substitution action, what is the meaning of this? If you have one compound A and B and you have some reagent C, so this reagent will come and they will substitute to B. That is a substitution action. So in the organic chemistry, what happens? You can say the definition one of the atom or group of substitute is replaced by another atom or group is known as substitution action. You can say, sir, in a CH4, I have I will replace one hydrogen and will add only chlorine also. Here I will change the iodine with alcohol groups. We can say here we are exchange the alcohol with chlorine also. We can say it is a substitution only. Okay. So here only sp3 hybridized carbon या aromatic molecule favor the substitution reaction. So if you observe, substitution reaction normally will happen in the alkane, alkyl halide, alcohol, and aromatic hydrocarbons. Okay. When I will teach, you will focus more. Then you will observe कि substitution reaction will come more in the halogen group, alkyl halide. Okay. And if you divide the substitution reaction into three parts, is also nucleophilic substitution means whenever your nucleophilic will attack on the functional group, that is a nucleophilic. Okay. When your electrophilic substitution reaction means whenever your electrophilic will attack on the functional group, that is a electrophilic substitution reaction. Okay, is also same thing. Okay. And this I will explain you. Okay, in the class also. Don't worry. This mechanism I will clear you. What happen here? Here also bromine will attack. What happen here? Free radical bromine will attack on the this methyl group. So that is a free radical substitution reaction. So this free radical bromine will replace one hydrogen. They will make here this bond. That is a free radical substitution here. Okay. Elimination reaction means key forward action is see here what happens. If you take Constantine H2SO4, what happens? This HOH and AOH will replace and they make double bond here. That is, whenever you are eliminate any elements from the compound, that is the elimination action. Okay. Here also they will remove bromine also and they will make alkene. That is the elimination. I'm not teaching you now reaction. I'm just teaching only definition only. Okay. It's not a substitution because see, I eliminate these two bromine, but I will not add some. See, in the substitution, what happens? If you will remove first element, then you will add another element. But here, I will remove bromine, but I will not any, and I am not adding any element. That is why it is a elimination only. Okay. For my question, what happened? Why not on benzene? What asking benzene? Which question you are saying? Prajwal, where? Okay, before it. Here? Okay, this you are telling this NBS. You are telling this. Yeah, okay. See, I tell you na. When you will take bromine in the presence of NBS, I tell in the alkene class today in the last. कि whenever you have what happen here, this will be make allylic substitution. Here allylic substitution will happen. So here double bond is there. If you suppose that here benzene substitution here, so that is why this connected this carbon. This is allylic carbon. That is why this bromine free radical will go to this carbon only. That is a free radical substitution of allylic. Okay. I will discuss in the class NBS high temperature at halogen. That is okay. I draw this also in a diagram today in the class. That is okay. And rearrangement reaction. Rearrangement I am telling you that today also 3 degree, 2 degree. That is a rearrangement. If you see here, conversion of one ester to another ester is the rearrangement. You can say, ki sir, sometimes for making the bond, we are changing the some elements. Yeah, we are arranging the elements. Like today we are arranging we have 2 degree option, but we go to third degree. That is a rearrangement. Okay, that type of reaction we call rearrangement reaction. Okay, and now from here Lalic LID will start. Okay guys, now I'm finishing this lecture today. Okay, I will share you with you guys notes. Okay, don't worry. That is a paper. Where is the reaction mechanism? This all notes I will share you in the class today. Okay, in your groups. Okay, and tomorrow in the class I will teach you how to get the haloalkanes. Who is that guy? Where? In the you are asking in the PDF. Who is the teacher? That is, yeah, yes. That is a different. Just leave it. Okay. Okay, Prajwal, I will send you video. Okay, don't worry. And today, tomorrow, I will discuss with you how to get halo alkanes from alcohol. Okay. Tomorrow class, I will discuss in the offline class. Okay. And in an evening class, I will discuss you allylic substitution reaction mechanism. Okay. Okay, guys. Now I am ending the class. Okay. And you will take the rest. Okay. If you have any doubt, you can also send me in a WhatsApp, and I will share the video also. Okay. Prajwal, you are absent now. I will share you video. Okay. Video. Okay, guys. Okay, guys. Now you can go. Okay. Thank you. Question paper I will discuss. Question paper I will discuss Prajwal. Okay. In the Monday to Thursday, next week I have 3 class I have to take. I will teach you assignment also and question also. GOC. Okay. Don't worry about that. Okay. Okay, guys. Thank you. Now you go. Okay. Take rest. Okay. GOC part. Okay. Don't worry. I have online class so much. So I will teach you GOC theoretical. I will teach you in a theoretical. I will teach you in a practical way. Okay. Don't worry, Prajwal. Okay. Okay, guys. Thank you. Now you can go. Okay, guys. Okay, guys. Now you can go.
No,
Bye
sir.
bye.
Teach something, sir. Sir.
I do not have no teaching something, yeah. That is I'm saying. Otherwise, I will teach you. Why I'm
Up to
leave you? 8:30.
8:30.
There is no rule. Okay.
Up
If
to
I will teach
8:30.
now more, so I think I will not come tomorrow. Okay. If I will teach more now, I will not come tomorrow. Okay. Okay. Don't worry. From next time, I will teach till 8:30. Don't worry. Okay. This half an hour I can compensate. Okay. Don't worry. This half hour I can compensate. Okay. Don't worry.
Okay, sir.
Okay. Thank you, guys.
Sir.
You can go now. Huh? Tell me.
Sir.
Yes, Tajak.
Happy Diwali book.
Happy Diwali book. No, understand. Happy Diwali book means.
Don't know Satoya. Say
Yes, sir.
in chat.
Happy Diwali books means this. I'm not understanding. Just tell me now what you're saying.
Planet.
You can
Planet.
plan the books.
Yes, sir. Yes,
You
sir.
asking organic books, na? Remaining alcohol, phenol ethers. This type of books you asking, na? L2
Oh,
azilimum. Okay, they will give you. Okay, don't worry. Alcohol,
okay,
phenol
sir.
ethers, and aldehyde ketones. Okay, I will tell you. Okay,
Okay.
okay, okay, guys. I understand what Harshit will write here.
Harshit.
Okay, guys. Bye.
Bye,
Okay.
sir.
Thank you for attending class. Thank you. Bye.
Thank you. Same to you, sir. Maya,